Kia ora, Year 12. This question is for Harry Bazier, and it's from the complex numbers booklet that I gave out the other day that I haven't finished off all the work solutions to. So Harry sent me in this one and said, could I have a go at 7b? Now 7b looks like it's going to be a really easy question, but if you read the examiner's report, it's pretty clear that lots of students spent too much time on this question this year. So I'm rushing out the door, so I'm just not going to do 7a for now. We're going to look at 7b. Now, there are several ways to do this question. So the way that I'm going to do it in this video is the way that I think most of you will do it, which is using double angle formulae. I think you can also do it using exponential form, but I haven't had time to sit down and try it just yet. So let's just look at what we've got. Well, we've got W has got modulus 1 and argument of 2 theta radians. So W is a pretty simple complex number. It's cis of 2 theta. So we're doing Cambridge, so we should write out clearly what we mean by that abbreviation. So it's used a lot in the NCEA, but I haven't seen it in the mark schedules for Cambridge papers. So there we go. So that's W. So now I'm going to go straight into the left-hand side and substitute in, and I'm going to get this. So W minus 1 over W plus 1 is going to equal cos 2 theta minus 1 plus I sine 2 theta. Divided by cos of 2 theta plus 1 plus I sine of 2 theta. Now, when I look at that, and hopefully by now, when you look at that, you're going to see a couple of things straight away. First of all, there's only one thing to do with the sine of 2 theta, and then we've got a choice about what to do with our double angle formula. But because we are going to be taking one out here, it makes sense with this one to use the 1 minus 2 sine squared theta expansion, because that's going to get rid of the minus 1, and then to use 2 cos squared theta minus 1, because that's going to undo the plus 1. So that's what I'm going to just get on with and do now. And then we're looking to have a whole lot of stuff simplify out so that we're just left with I sine theta over cos theta. And so you look at this and you think, oh yeah, this is going to be quite easy. And it sort of is if you have done lots of work with proofs. So in the numerator, I'm going to go really slowly because it's a show that question. So 1 minus 2 sine squared theta, take away 1, plus 2 sine theta cos theta times I. And in the denominator, I'm going to get 2 cos squared theta, plus, take away 1, plus 1, plus 2 sine theta cos theta I. Cleaning that up with the obvious steps, I get left with this. Negative 2 sine squared theta plus 2 sine theta cos theta times I over 2 cos squared theta plus 2 sine theta cos theta times I. So we can divide through by 2 everywhere in there, and I'm going to do that now. So let's just get rid of those. And then if you look at where we're trying to go, we want to end up with I tan theta. So the obvious thing to do now is just to factorize easily what we can in each line. So you can see we've got a common factor here of sine theta, and we've got a common factor here of cos theta. So we're looking pretty good. We've got sine theta times negative 2 sine theta. Whoops, we've lost the 2. So negative times negative, where am I? Negative sine theta plus cos theta times I. And here we've got cos of theta times cos of theta plus sine theta times I. So you can see that we've got tan theta, and we want to have I tan theta. So I'm going to multiply in, I'm going to leave the cos theta plus sine theta I here, and I'm going to force in that I. So if I'm timesing in the I, then I'm going to be dividing it out. Right, so I'm taking out a common factor of I. So here I've got cos theta, and then I've got minus sine theta divided by I. And now we're just about there. So it's actually not that bad. So we've got I tan theta times cos theta plus I sine theta. And up here, we're going to go really slowly. We've got cos of theta minus sine theta over I. And I'm going to times that by I over I. Times that by 1. That leaves me with I tan theta times cos theta minus I sine theta in the top line divided by I squared, which is -1 over cos theta plus I sine theta. Right, I'm going really slowly with my steps because it's a proof question, so we want to show that we really get what we're doing here. So you can't just hand wave from up here and go, oh yeah, we're done, right? So that's not how it's going to work. So minus -1 minus divided by negative gives me cos theta plus I sine theta. And look, finally we've got the common factor that we were after. So that equals I tan theta as required. So I think if you use the technique that we've used quite a lot, especially in scholarship sessions, of forcing in what we want to have in the end, right? So we want to end up with the I here, and we don't have it here. So we're going to times it in here and then get it out as a factor here. So we have to divide through by that. So that's one way to do that question. The other way that I did it that worked quite nicely is that instead of using the double angle versions that I did, so instead of doing this one back here and this one, I used cos squared theta minus sine squared theta. So there's quite a lot of different ways to attack this question. You might want to just try a couple of different ones. So Harry, I hope that helps. And hopefully everyone else is watching, because this was, I thought, a really good, tricky, complex numbers trig problem. So just keep on sending in the questions and I'll try and do some more videos later on tonight.